Everyone should be receiving their pizza pretty soon if you haven't already. If you have any sort of problems with that, any questions, you can feel free to shoot me an email at TylerN. That's TYLER, N as in November, at AMI.com. And I'd be more happy for you guys. But again, should be starting here in just a few moments, so just stay tight. All right, good afternoon, everybody, and welcome to Store Trends Presents SSD Hybrid versus Full Flash. My name is Tyler Newberry, Level 2 Marketer for AMI Store Trends. I'll be your host and moderator today. We'll be getting started here very shortly with the technology presentation and all that good stuff. If you registered before Monday and you ordered a pizza, it should be arriving here shortly. If it hasn't arrived already, if that's any more than 5-10 minutes later, so go ahead and shoot me an email. Let me know. We can track that down for you. Again, if you registered before Monday, when the registration deadline, again, that email is TylerN, TYLERN as in November, at AMI.com. And if you have any questions throughout the presentation, please email them to that same email, TylerN at AMI.com. The reason that we ask you to email those questions in is so that if we have any questions that we're not able to get to on air due to the time restriction, we can email you the responses this afternoon. And we're going to be very respectful of your time today. We'll be wrapping up right at 2 p.m. Eastern Daylight Time, or just a smidge beforehand, so you guys can get back to the office and do what you need to do for the rest of the day. However, with that, we will gonna go ahead and start moving on to the agenda for today. So looking at the agenda today, we'll just do some quick introductions, looking at flash storage and IOPS, what those mean. Take a look at hot data. What is hot data? How is it relevant to your infrastructure in your data center? Take a quick dive through some Store Trends customers. Look at some of their stories and see if it, how it applies to, other environments such as, maybe yours. Then we'll actually take you through the UI for a live demo, and then we'll wrap up for the rest of the day with a Q&A session with any questions that you submit during the event. And like I said, any questions that you have during the event, feel free to email those to TylerN, TYLERN as in November, at AMI.com. But without further ado, it's my pleasure to introduce you to your speaker today, Senior Solutions Engineer, Mr. James Dyckowski. James?
Thanks a bunch. Like Tiger said, we'll kind of go through all the different options between AMI, hybrid array, full flash. We'll jump on in here. So you can see here the introduction to AMI. Who are we? What is American Megatrends? And you can see the triangle either in the center of the screen, kind of to the left, or in the top left of the screen. This is the same triangle as what you would see in the BIOS. We've been doing BIOS for nearly 30 years, as well as we have a bunch of other product lines that are usually not normally heard of, like the Mega Rack product line, which is remote access controller. So usually when you can log into directly to your server and see the actual screen, the actual console, that's usually our product that you're actually seeing. We just OEM that out to other companies. And then also the LSI Mega RAID controller. So this is more of what we're going to focus on today in that direction, as obviously that's the underlying base for storage in any vendor as you see it. So the LSI Mega RAID product line, that was actually developed by American Megatrends, and we sold that to LSI Logic in 2001. We took back that same team after the no compete, and now we've actually built the StoreTrends product line for that. And we've been running with this for probably the last 8 years or so. So we've been around for 30 years. We have a worldwide presence, over 1,300 employees, and this is growing daily. And we are in some way or somehow over half the computers in the world today. Specifically, we have over 100 patents and well over 1,100 installs. Actually, that number is a little old. So our mission statement is to provide you the highest quality product the first time, every time, and we stand behind that. So now we'll kind of talk about hybrids, SSDs, spinning disks, IOPS, and all that. And so the base for this is really, what do you have today? What's in your infrastructure? And 9 out of 10 people that I talk to have some sort of spinning disk array. They're striping a bunch of shelves together to get this aggregate IOPS. Basically getting as many spindles together, and each spindle has its own correlating IOPS for that. So what we do is here we're comparing two similar solutions of the legacy solution of striping disks and the new solution of doing a hybrid array, maximizing the SSD performance with IOPS, but then also maximizing the space and spindles with spinning disks. So you can see here similar solutions capacity-wise, which is that's what in general your requirement has to have. And then we're looking at 4 times more IOPS, though, with the SSDs. Now, our technology, we're kind of doing caching and tiering with SSDs, and we'll talk about that later. But our technology enables us to capture the hot data, the most recently accessed data, into the SSDs only, and then also kind of manage the underlying slow spinning disks for the colder data, just to keep it safe and accessible. You can see here it's just a lot more efficient. You're looking at 5 times less rack space, way over half the power. That kind of correlates into your CO2 emissions, so it's a greener solution. And you're just managing less disks, less rack space, all these kinds of things. The upfront costs are cheaper, so there's a simple argument just up front. Plus, your operating expenses are substantially cheaper as well, at a 50% OPEX savings. So these are just standard numbers. You know, here we have an EMC. This doesn't have to be an EMC. This could be any spinning disk array, including a StoreTrends 3400i, which is all spinning disks. So, and it's just the hardware that you have available. So we're kind of limited to the technology there. And so now we're just kind of moving forward with SSDs. Okay, so now we'll talk about what IOPS are. At the bottom, I actually have put Tyler in at AMI.com for any questions that you have as we go through. If we see it and it kind of pertains to what we're talking about at that time, we'll go ahead and just slide it into the conversation. It's no big deal at all. We like to try to keep it wide open, so feel free to email anything. So now we'll look at IOPS. Now we're going to look at the application side for IOPS. So we have different types of users. This is actually from VMware's website, and you can see you just have task users, which are maybe in a library, maybe on Google Chrome, just looking up something on the web, maybe working on a resume, something like that, or maybe even on Google or YouTube, watching a webinar like such. knowledge worker, so this might be more like me. I have a few applications open. I have the PowerPoint open, Outlook, Google Chrome, and I also have an RDP session going in the background for my lab system. So I have, 4 or 5 apps that are kind of pinging, they're doing stuff, they're getting data. So I would be in more the knowledge worker area. Then you get into the power users and the power user standard and heavy, to where they're doing maybe CAD drawings, multiple monitors, stuff like that. So you have to factor in a bunch of different IOPS. And so what these IOPS are, they're just individual block accesses to the disk. So you can see here 3 to 7 block access to the disk for a task user. So basically it's just one app that's really, kind of getting used effectively. So now you just kind of extrapolate that up. With the computer intensive, sometimes that really goes into one app, but it's multiple layers, so they have so many more processes going on. Another side note, which the 1 CPU, 1 gig of RAM, that is for x86. If you go to 64-bit, you do need to step that up because it does hog a little more resources to run. So if you do have applications and stuff like that that require 64-bit, that does have to go into your factor. But really what we're focused on are the IOPS here, what we're actually looking at to the disk side. And so now, so the VDI piece, so those users, that's fine and great. And that's really where the need comes in for SSDs, because a lot of people are really moving towards this all virtualized environment. So now the baby step was really VMware, Hyper-V, Citrix, Zen, and getting your servers virtualized. But now it's like, okay, well now I have that step. Now let's secure our actual end users' data and get every individual user out there. Well, if you have 10 users and say they're booting, so you can see here 100 to 120 IOPS per user for boot, 10 users is 1,000 IOPS. Now we'll kind of talk about, because 1,000 IOPS may seem nothing, if you're talking about gigahertz or something like that. But really, in the IOPS world, that can be a substantial amount, especially for spinning disk technology. So you can see here, though, on the top part, virtualization VDI. So just like VDI, they're just individual VM instances, but it's just there's so many more of them, it extrapolates the numbers and makes it large. So for a standard VM, you do have the same kind of accommodation. So, an idle versus an active VM, a SQL server, say that's virtualized or something like that, might be, and it's a centralized database for the whole company. Maybe that's on the 30 to 40 IOPS type range, to where maybe a DNS server, DHCP server is going to be down around 5 to 10 IOPS, just depending on how many people are actually accessing it, of course. So booting, so this does matter for VDI. So each individual user does have to boot up eventually. And so that does cause I/O strain to the disk. So that's where a lot of accommodations come in when you do have, multiple users booting at the same time. Say there's just 10 at the same time. That's 1,000 IOPS. Well, at say 150 IOPS per spinning disk for a nearline SAS drive, 10 SAS drives, and that's basically everything that a VDI boot for 10 users can accommodate, pretty much. So plus you're running other stuff as well. So there's a lot of factors there that can easily hog your system, let alone 100 users. You're looking at 10,000 IOPS. So you can see here the block size. So 4K is the NTFS block size, just in case somebody didn't know that. So that kind of goes into throughput and other bottlenecks that we need to worry about just down the road. If you guys ever have any questions or whatnot, you just talk to us, and we'll basically make sure that there are no bottlenecks for your infrastructure. And then you can kind of see here what the IOPS per server is, just in general, in these different situations, the averages. So now, what are they on the application side? In general, we don't even care anymore. It really goes down to iData, and we have a tool that'll basically monitor all your servers, tell us what these just arbitrary IOPS are, and handle it. But if you wanted to know and really needed to understand what's happening, so you can see here the latest Exchange servers are 32K block size, so we can get kind of a throughput by multiplying that by the IOPS, so 3,000 IOPS here, and you can see what the IOPS per email is. So if, olden days basically, if you had to take each individual user and say, oh, they do 50 or 100 emails a day, you can kind of figure out what the IOPS per email is, per user, per environment is, and kind of go that way. Same thing with SQL, Oracle, kind of figuring out how many transactions your environment would run, and then kind of extrapolating that down to the IOPS per transaction. and what's more efficient, what's less efficient, and kind of those kinds of factors. But anyway, so it all comes down to IOPS, down to disk, as one bottleneck. That's a primary bottleneck, and that's what we're going to focus on today with SSD technology, flash technology. But we do have throughput considerations, and then outside of that, you really go into your CPU and your memory considerations on the virtualization side or the actual hardware side for the server. But we'll move on. So now we'll look at this from the actual disks. So what do you get from hybrid versus spinning disks? What does it take? What is the match? So this is an actual mixed workload environment for all these numbers here. So you can see here, we're not doing just all reads or some marketing numbers. With that being said, so it'll take 96 spinning disks to get at a 67% read, 33% write, just kind of normal random workload. It'll take 96 disks to get up to what just simply 2 SSDs can support IOP-wise. Okay, so we'll have to worry about, obviously, capacity factor, but you can see there how big of a difference that is. So that's a lot of enclosures, a lot of power wasted, just a lot of management overhead to kind of compare the two in their maximum random I/O load. So now, just like spinning this though, as you add, you can just simply add IOPS as well. So you can see here, we basically double the IOPS from 30,000 to 60,000 and double that up again to 120,000 as you add SSD disks. So, and then of course a full flash array, so now you're getting up to 250,000 IOPS. So everything just kind of extrapolates up and works together. So we're looking for that green solution, being efficient as possible with your SSD drives, and not wasting any money though also, and we'll talk about how we do that. So we'll go into here. So now we're going to talk about the application of hybrid storage. Just how does this work? What in the world am I talking about? And how does this fit into your environment though? So, and again, please email any questions to Tyler that you have, and we'll try to get to them as we go. So we'll talk about automatically tuned volume. So this is one of our new features. It's a very nifty feature that allows you to kind of just basically maximize your space. So we have multiple tiers. Tier 0 will be the SSDs. Tier 1 will be 15K SAS drives. Tier 2 will be nearline SAS drives. You can have any mix of these. You know, if it was no SSDs, we would probably do a 3400 instead of a 3500. But either way, you have this technology available to you to kind of maximize your space. So the SSD space in this situation is the most critical, most expensive, and the highest I/O needed volume. So we'll basically pin that up to the top volume, and what will happen is within the volume, though, we'll actually demote blocks that aren't accessed at all. So now that leaves more SSD space for other applications, or maybe even just more space for another SQL database or whatnot. So over time, this really gets super efficient. And it's using our tiering algorithm that we've had for probably about 6 years now. You can see here Tier 2. So Microsoft Dynamics, it's very similar to Microsoft Exchange, to where you have this 32K block size going on. And it's a CRM type situation, so it's just a lower access than what we'd expect from a SQL database. And then VDI, we kind of have that in the middle. There's a kind of a way to break that apart into multiple instances to where you kind of maximize the space in those instances. And then backups would kind of go down on your lower spinning drives. So we don't waste any SSD space on, you know, backup snapshots from, say, it's an active-active DR situation, or just your simple backups from SQL or like a Symantec BTL type situation. So that's kind of how that works. And so now what are we doing underlying? So we have an actual volume here. This is just pretend like it's any one of those. Actually, even better would be the SQL volume. So we had it as a high-profile volume in that previous slide. So now, say one of those blocks that got demoted because they weren't accessed, it's just an old block, whatever, but now all of a sudden it's getting accessed. So what happens? So of course, with our caching algorithm, so we have 2 disks that are out basically pinned to be the caching drives. With that, they're going to immediately promote this volume up, or this block of the volume up to the cache, and immediately just read from that. Now, if it's written, actually we have a write partition within the cache that gives you a minimum of 64 gigs worth of space to basically allow you to just simply write to it and be done. So now you're not getting hard drive write performance. You're just getting read performance one time, and then it's all fed from the cache. Now, Say it doesn't get accessed again, it's cleared and done. You'll basically just let it resolve in the cache. So say it continually gets accessed. What will happen is that the blocks that are hit heavily, basically, will then start promoting into the tier, as you can see here, going from left to right. And the data now is kind of coming from either cache or the tier, just depending on where that block is. But the key is it's coming from the SSDs nearly immediately. The only factor is if it's read from the hard drive initially, filled into the cache, and then from there on. And you can see why we get a huge benefit here is with the SSD space, we have this minimum of 64 gigs worth of write cache. If you look at our competitors, they're doing NVRAM cards or something like that, which are substantially more expensive. And they're actually having to mirror the cache across controllers, whatnot, where we actually have this just sitting in a RAID set within the cache. So it's already fast just by doing that. We don't have any latency added up there. For the read cache, the rest of the disk is available in a RAID 0, which is high performing and also just fully available to give you the max amount of space. So say we see this block being continually accessed, though it becomes from just basically green, which is medial access, whatever, to actually hot access. Then it'll just simply fully promote into the tier, and it'll just get read and written from there. So we kind of go from there and all that stuff to maximize your performance, maximize the SSD space that you have, and make sure that you have everything as efficient as possible. And this gives you the most performance from the live latency reduction that you can get out of just an arbitrary block being accessed from a particular volume. And another note, you can expand these SSDs on the fly either for the cache and or the tier. So you don't have to worry about a controller upgrade down the road because, oh, you know what, we bought a business unit, or oh, Dad, we wanted to add so much more stuff to this array to kind of maximize that. So,
James, I could for a quick second. We actually had a very good question come from a viewer out in Ohio, actually, kind of regarding write cache, and he just asked actually, why is write cache size so important in these different types of environments?
Okay, that's a very good question. So write cache is so important because the hard drive, there's a huge hit on RAID sets. So if you have just simple, this 150 IOPS that I was talking about, that's a 150 for reads. So if you have, say, 10 disks striped together, you're looking at 1,500 for reads. But for a RAID 10 even, there's a by 2 hit on that. So now you're looking at 750 IOPS if it was only 100% writes. So now we're looking at 1,500, 750 IOPS. Well, if it's in a RAID 5, that's a by 4 hit. So now you're going to have that again to 375. So now there's a substantial hit there. By us writing to the cache, we're looking at 25,000 IOPS because it's in a RAID 1 with the 50,000 IOPS that are reads from the SSD drive. So there's obviously a huge consideration there and a huge deterrent from writing to those hard drives and making sure that we're kind of maximizing your performance there, not only the SSDs and stuff like that. So hopefully that answers your question. Please reply back if it doesn't, or if you have an additional question. And we'll kind of move into, so now we'll talk about the actual applications, now that we've talked about what our technology kind of does internally. So here you can see just a standard Horizon View deployment. They're all very similar between Horizon View, Hyper-V, Citrix, whatever. So you don't have to worry about that. Effectively, we're looking at storage, we're looking at a back-end SAN network, and then we're looking at just servers and sharing resources, giving those out to their individual desktops. There are infrastructure things like the vCenter server, Active Directory DNS, and all that kind of stuff. So that's the standard setup, just to kind of get a picture. So now all these guys are accessing these volumes. So what we've done here with volume pinning and automatically tuned volumes, so we can set these volumes to be where we want to not waste any space. And the biggest waste of space is like the golden image. So you can see that down on tier 2. We can just pin it down to that lower tier and make sure it doesn't exceed that at all. And what happens is the golden image gets the replicas spun off of that. They're just complete duplicates, replicas of the golden images. And what happens is those then duplicate all that space, though, into the SSDs in this case. So we'll pin the replicas up to the SSD space so that all the desktops can spin off the replica. So if you have those 100 VMs that are booting at the exact same time, you're looking at 10,000 IOPS. It would take a lot of spinning drives to get to 10,000 IOPS. Probably about 30 or 25, just thinking about the 96 drives it takes to get to the 60 or to the 96 disks that we had before. So so here you can see the replicas. They're going to get all the I/O from each individual desktops. Each golden image is going to be for one individual department, stuff like that. And then you have this temp OS space. So you can really kind of design this in a bunch of different ways. But here's just kind of an example. So we have this temp OS space that's sitting in Tier 2 as just to have the actual data sitting on spinning drives on RAID. But the cache is going to just simply handle this. So we can kind of enable high profile for tier type for a volume and or the caching as well. So we can adjust all these things. But the temp OS space is the individual desktops. They think they're actual VMs. Well, actually, they think they're actual desktops. And so what they're doing, they're writing all the system files, they're updating logs, they're doing all these things that in a linked clone environment, this all gets just completely thrown away once they log off. That's temporary data. So we can just simply cache it, alleviate ourselves from it, and be done with it at the end of the day. So we can just simply use cache for that. The user space, so say you have some persistent disks, maybe everybody's persistent disk, stuff like that. You can kind of keep that in a middle zone there. Maybe once the sub-blocks from the replica volume start demoting down, because really the heavy hitting piece of the partition is the actual OS system files. So then the user space will have space to get that SSD performance just later on. And that's a big note about our solution. It gets faster and faster as you go, more and more efficient, because we are watching exactly which blocks are heaviest hit and where they need to be located at. So just a note there. And so the same goes for databases. Everybody divides these up into logs, database, tempdb, stuff like that. And so what we have here, we have the SSD tier layer. And so what we're trying to do is divide up the volumes for what is the heavy hitting data here. And one thing down the road, probably a few minutes from now, we're going to get to, is this actually, I mean, this looks like a cute concept, but is it true? Is this actually how it works? And we're actually going to prove that. So anyways, databases, you have hot data, you have cold data. And cold data can be one access a week or one access a day, but it's still just not the hot, heavy access data. So we'll kind of go to here. We split these things up. So like I said, we have the database. We're going to keep that pinned in the SSD tier. Just leave it alone, give it that space, and done. It can do whatever it needs to do. Now logs, normally you would want that kind of just written and done, but it's not a lot of data. So cache can very easily handle that if you're kind of worried about space. It just doesn't matter. In your situation, if you want to put the logs in the SSD tier, it's fine. But in this instance, we're just kind of doing this as an example. TempDB, you can see here, we just have that in the cache. For one particular customer, we have them kind of putting everything together throughout the day. Then that TempDB actually gets migrated into the database, kind of converged together. So that does need to be in faster space, but at the end of the day, it's actually temporary. So we kind of manage all these type things. And then indices is kind of, it just depends on your situation for how many times that you guys access indices, if you do have a database deployment. And then snapshots. This is old data. Hopefully you don't have to access it because you've had some sort of issue with your database, corruption-wise, hopefully. Hopefully you're just recovering something, but they need to be there. However, they're usually not heavily accessed. Even if they are, you can mount them up. You can give them a high profile and still get, that performance if you did need a realistic kind of sidebar test of a database or something like that. And so then we have like backups. So this is one thing we've been doing for quite a few years now, probably 6 years at least. But this has been our bread and butter actually before this SSD cache and tier has taken off since January. And what we have is we can have active sites, active passive DR sites, and we take our snapshots. We have redirect on write snapshots, so we're not taking up any additional space or anything like that. And we just basically ship those off to the other side. We do have to have our own unit there, but that's because of the WDS engine that we have running between them. So that's wide area data services. And if anybody's heard of like a Riverbed or like a Silver Peak WAN optimization technology, we have that same type technology built into our replication. So we optimize the link. If you compare, so we've actually compared our optimization to the other's optimization, you're going to pay 10 or 15 grand per site for their optimization, and it's only going to be a 5% increase over what we're doing. So we are doing this very, very fast. And then even better, we're compressing and deduping these blocks to reduce the amount of data sent. So your RPO is completely increased on the other side. So if you did have a disaster, it is pretty much as fast as you can possibly be in sync as possible. And then we do provide encryption if that's required by your company, which of course we have customers that require that. So now how does this kind of fit into the flash piece though? And so you don't want to just have your dumb snapshots going to the SSDs. We pin that volume down to the slower tier, basically just give it the capacity to back it up. You know, you have the DR space here, the store trend snapshots, you have the VTL, SQL backup. But you know what? Say this is kind of manager versus. And so one thing with store trends about support you can get, I don't know to tell you. From 1 to 5 years, 7 technical phone support. Of course, next business day extensions and stuff like that available. But we do have remote email alert monitoring. So our support team has a full line tap into what's going on in the unit. If a controller fails, if a disk fails, if a fan fails even, we'll know about it. Going to the disks piece, we actually do monitor the actual medium errors on the disks. So we'll know ahead of time if a disk is about to fail, and once it crosses our threshold, we'll go ahead and actually just send you out a drive ahead of time, let you replace that either in the evening or the weekend, just to alleviate any form of possibility of degradation performance-wise. Now, one thing about that, we only get a 5 to 10% degradation during downtime. And this is because we have an I/O offload engine during downtime to where any writes that would happen to that array, we'll actually offload that to another array and make sure that this one can A, be in sync as fast as possible to the spare drive or whatnot, but then also maximize the performance that you're seeing. So, so a huge advantage with the storage support program that we have. And that is here in the AMI headquarters in Atlanta, Georgia. That's where the support center, that's where the calls come in, all those kinds of things. So there's no question about who you're talking to. And then, of course, Storage Plus support, we have a 4-hour on-site for that to basically handle any kind of late-night issues that you might be worried about. Like I said about the DR piece, we can replicate to any of our units. This is the same software stack. We haven't gone crazy and gone out of revisions and done this and that. We've worked them all together to make sure that, you know, any customer that needs to upgrade to a newer unit from a 2400 or 2401 single unit, single controller unit to a 3400, 3500, they can just seamlessly do that. Or just simply, you know, have a 3500 on a primary and say at 3400 just to keep the data safe, but they kind of want it on dual controllers. And you can kind of mix and match what you do there. So it gives you a lot of versatility. And we go up to 256 terabytes with 3400 and 3500. So it gives you plenty of capacity to kind of work with, grow into, etc. Okay, and so now we'll kind of go into hot data. So now we're going to talk about the StoreTrends iData tool, which is brand new to us. We're very excited. We released this at the beginning of March. We've had a lot of installations with it and actually seen a lot of great things, kind of validating both ends of what we see in our own reporting tools, but then also what we're actually sending to customers is more and more accurate. Again, please email any questions, Tyler, no problem at all there, and we'll kind of talk about this piece. So It's very simple. You just set it up in minutes. You can download it from our website. If you go to storetrends.com and then resources, you can just see the iData tool right there. Download it. It's free to download, use. You send the iData report to the Store Trends team here in Atlanta. They'll get an engineer on it to run it, go through all the logs, make sure that everything looks crystal clear bottleneck-wise, IOPS-wise, give you a recommendation for any kind of questionable pieces that might be in your infrastructure, whatnot. And then they'll send you a detailed PDF with the overall infrastructure, and then B, the individual servers and kind of how they're broken out, IO-wise, CPU, memory, and all that kind of stuff. But even better, with us, we can actually identify what the active and what the cold data is from our reporting tool here. And with that, we can actually really scope out and find out, hey, exactly if they want SSD space, if they want a hybrid, what exactly do they need? We're not going to waste your time just giving generic numbers out and saying, oh, yeah, this is what you need, because everybody is different. And we can actually show that actually at the slide after this one. And this just kind of gives you an infrastructure. So we have the Square server. This is just the utility server, something on the network that can access everything. You install the iData tool there, and then you just put in the IPs of the individual servers you want to monitor. So if you have an Exchange server, SQL server, or a VMware vCenter server, if you put in the vCenter, it'll actually just pull in all the hosts automatically, so you don't have to do anything there. And then kind of a sidebar note that we kind of added afterwards was, hey, we can actually scope out VDI deployments with this. So we had the little Windows 8 emblem there to really see, if you have all these different departments, they're going to have their own golden image like we talked about before. And so what kind of applications are running are all different between departments. For us, it'd be engineering, sales, accounting. Our CEO would be a whole separate thing. And so really you can kind of focus and figure out what each department needs and really get just down and dirty to exactly what you need for a VDI deployment profile-wise. So we get a very good scope there. So now, so the hot data. So now, how does this iData tool help us? And then how does this work into what we report? So you can see here, this is infrastructure data. So these are a couple of our customers. And these are customers we've had for a few years, actually. So we get a very good idea of where this data is, how old it is. And you can see here, so the gray, that's cold data. So it's data accessed over a week. So then you have the blue, which is kind of that's the week-old data. It's been accessed at least once within the week. Maybe it was part of a backup. Maybe it was just new data from 6 days ago. We don't necessarily know that, but we can tell how much it is at one instance in time. And this helps from both sides, from our side as well as the iData side. But more importantly, you can see the day, the hours are bright red, and then the yellow is 100 plus. That's 100 plus individual accesses, and this could be up to 100,000 accesses within an hour. But that's the yellow piece. So that's the stuff that's really getting hit over and over and over. So you can see there, it's a sliver, and that's really where you need the SSD space to accommodate. So you don't know exactly how much of the data within the hour was in that yellow piece from the previous hour or whatnot. So you do have to scope a little more than that. Obviously, you can't get that granular, as it does take time for tiering to handle that. But what StoreTrends gives you is that extra caching space. So now you can really get real lean with that. So here we have 10% basically covers your hour worth of data plus some daily worth of data. And even that day stuff, I mean, that could be accessed once within the day in this consideration. But the main piece, so 30% definitely covers a day, 10% definitely covers within an hour of your most recently accessed data. So now when people say, oh well, we'll scope this out for 20%, you can kind of look at this and say, you know what, I actually saw this thing, and they actually showed how much data gets hit. Now, you can see Company D up top there. They do have a report that runs wild on one of their SQL databases or a few of their SQL databases. And so it does actually cover a lot of data on the weekend report. So you can see they do actually access more than normal. And so this is where customers are all different. Everybody's environment's different. And there's just nothing we can do about that. So now if you look at databases, So databases are a lot more lean in general when you're looking at just how much data is accessed. And you can see company G there, they have the same type weekly report. It's just not as bad. They require more information. It is what it is. You can't do much about that. But you can get away with a lot less SSD space when you're looking at the overall infrastructure for just databases, or the individual storage space, I should say, for the databases. So you can kind of factor that into the equation. And what this does, it just simply backs up what we normally talk about with this 5%, 10% SSD space that normally gets quoted out for everybody. But you can see here, we do have this company H. I mean, they're 20% of their data gets accessed within a day, 21, 22%. So you do have those kinds of factors that are in there. And, you know, how much SSD space you get is the factor of how much money you spend. So what do we report? So that was kind of the iData, and then that was meshing actually the iData with our reports to show these individual customers and kind of see where we're at. So here's an actual customer's ILM chart. We've had permission to show this and stuff, so obviously everything's okay. It doesn't really show any raw data, it's just showing numbers. But with that, what you can see with our mechanism, you can see the tier 1 and tier 2. Now this is all spinning drives, and like I was saying, our store trends array gets more and more efficient as we go. So what happens is, even in the spinning drives, you write to the outer tracks up front, which is great performance. But as it fills up, you actually write further into the inner tracks of the disk. And what happens there? It's slower. It's actually half the performance from the inner tracks to the outer tracks. So we actually manage the blocks within the spindles as well as the outside tiers of SSDs versus 15K SAS and nearline SAS. So we're kind of monitoring all these things, and it literally does get faster as you go. We have a few customers that we can talk about that. You could, if you want references, we can give them to you about this. So anyways, what you can see here, the main piece, you have tier 1 and tier 2. Look how much hot and warm data is in tier 2. We're looking at 30 gigabytes. How much is in tier 1? Almost 2 terabytes. So this data is randomly getting accessed, old data, and it's promoting up to that tier 1. It is keeping it full, making sure that, hey, if some of this random access came from, you know, the class 1, so the old data on the tier 1, it'll just simply move up, you know, within that tier. So you can kind of see how this works. So just a note about what we're doing internally and where this technology really is for the store trends arrays. Hybrid, all flash configurations, everything's available for you from us. And then even obviously spinning drive configurations. SSD caching and tiering, so this gives you a great mix of dollar per gig and dollar per IOP. If you actually mesh the value together of what you're getting, because our technology is giving that to you, it's huge. We're highly competitively priced with every other vendor out there, plus we give all this stuff. The features that come with this are also all-inclusive, so we're not nickeling, diming for, oh, you want replication, oh, you want zone bit recording, which is the tiering within the disks. We don't do any of that stuff. You can see the automatically tuned volumes comes in this, and it gives you that quality of service for your volumes, or at least for the volumes that need it, and maybe a degradation of service for the volumes that they don't need performance, but we're not going to waste that space on the other end. So you can kind of make sure that you're maximizing that. And we can do on-the-fly expansion with SSDs for the caching and or the tiering, whatever. And that just avoids these forklift upgrades that other vendors would. They'd undersell you on the SSD space, so they'll get you on an expansion shelf later on, or they'll force you to upgrade the controller, which is who knows how much money, as opposed to just simply pull the drive, put the new one in, and done. We do also have the support if you just went crazy buying another business or something like that, forgetting about a business unit. You can upgrade these hybrid configurations to all flash and make sure that you're not having a forklift upgrade there. So 250,000 IOPS, basically just an all flash strike together, and this just gives you a huge latency reduction. The live latency reduction, we say plus 10 milliseconds because what is the latency for a nearline SAS drive? 14 milliseconds in general if it's fully loaded, and then 7 milliseconds, which is half for double the speed of a 15K SAS drive. So you can kind of see how that kind of works together. And the sub 3 milliseconds is averaging out everything together with reads coming from disks, writes, and all these things kind of going together. And we support, or we give the numbers from the actual application. We don't give the numbers internally to the array. We're not doing that marketing-wise to lie to you, as some other people might do. We support high performance databases, virtualized anything, VDI, mixed workloads, all that kind of stuff. And we have deployments for everything out there. You know, this Store Trends array, it's come from the Mega RAID controller product line. This is the foundation of our team, and it's 90% of the same team that was there years ago, and the good 90% even. So 30 years of IT leadership from American Megatrends, and we're literally in most of the computers in the world. So it's hard to not trust that name. And we have a lot of Store Trends installs worldwide. So a lot of factors there considering that. One thing that was just released, we do obviously tout performance, but what does that mean? Me just saying that we have performance, that doesn't say anything. So, you know, Tenasia Group, they saw the 265,000 IOPS, they saw throughput, they saw all that stuff. They saw a lot of feature stuff. SSG Now at the bottom, they kind of went through the iData, said it was great, easy, and very just non-intrusive to the environment. But Storage Review, they actually just went through our unit, compared it to what they've seen from Ecologic, HP, NetApp, XIO, and compared it. And we were at the top of the list for all tests in that. So go to storagereview.com, check it out, see it for yourself. We didn't pay them a dime. They won't take a dime. You know, nothing like that. So it's a true evaluation of the exact same test, and comparing these numbers together shows you our performance, shows you our value that we give you. So anyways, please, by all means, look that up, check it out, and see what we're talking about. We have a couple customers here. You know, just different environments is the idea here. We have databases, email, VDI from Charlotte Radiology. RTI is strictly high-performance databases. Global eProcure, you know, they actually are databases, but highly virtualized as well. You know, they have a bunch of clusters that actually replicate to each other. And then University of Maryland, they're actually a heavy database with DR type situation as well. So a lot of different types of customers, stuff like that. And we have probably a customer that has your similar type situation to basically as a reference if you need to talk to anybody, you know, if you don't trust us, or if you don't trust Tyler for that matter. So that would kind of go to this piece.
Yeah, speaking of not trusting Tyler, we had just a couple of questions come in throughout the presentation, and we just kind of wanted to address some of those good ones. And like I said before, if we don't get to answer everybody's question today because of limited time frame, and because we want to be so respectful of your time today, we will certainly make sure we answer all of your questions via email this afternoon. So please don't stop emailing, don't stop asking questions. We had another question regarding write caching. Seems to be kind of a hot button issue out there. We've had multiple questions on that at this point, but I think the one that sums it up best is what happens when you're out of write cache, both in Store Trends arrays, James, as well as in our competitors?
Okay, so that's actually a really good question. So there's a few facts. A, you can upgrade the cache. We would love to sell you more SSD space. It's fine. But if you don't have that availability, say there's read cache space that's wide open. We actually have the availability to increase or decrease that space based on just a little slider bar that you would just simply update. So it'll give you more SSD space for write cache. Or say it's the opposite, you don't have any write cache being used at all. You can just simply knock that down to 0 if you want to, and just have all read cache. So you're kind of maximizing that space however your workload desires. When it comes to other vendors, if you run out of cache space, you have to upgrade the whole controller, because most likely, other than one other vendor, only one other vendor actually puts cache space in SSDs. They don't do tiering though. But of the other ones, you have to upgrade the whole controller basically, which is a very hefty charge to your end.
Very good, very good. We had another question come in regarding video data, and it's just, would your solution save video data the same way that it would save regular data?
Yeah, so with volume pinning, we can basically say, you know what, if you have, say it's a video camera type deployment or something like that, you can basically pin that volume down to the lower tier so that you're not wasting the SSD space on that. If you did want to, if you say you have, there's some deployments to where people are working on video and stuff like that, and they have one mainstream, and then they want that into SSDs. So it is the most recently accessed data. You would basically have that volume as a high-profile volume, and what would happen is all that new data, the new stream of data would come in. It's fully available on SSDs. Say you just needed extra space, you can use caching to kind of buffer for that. But what will happen is everybody will just be accessing that, duplicating it within the SSD space, and then kind of working on it, editing, just depending on what your situation is. So there's multiple different kind of ways of dealing with it, depending on if it's a video camera type, surveillance solution versus a video on demand or actually video editing type solution.
Very good, and I think this actually leads in perfectly into the demo. We had a couple of questions on kind of usability of the UI and how user-friendly that was. So I think it's a perfect segue to go ahead and transition over to the demonstration.
Okay. So I just simply logged in. I wanted to show the slider bar. I didn't quite have it exactly up and ready. So you can see here, this is our SSD cache statistics. We show endurance right here. Right now it's at 99%. These disks are about 1.5 years old. So you can see they're actually very well maintained, as well as even the tiering drives that are for SSDs. And in here you can see kind of, the resized write cache. Right now it's set to 64. You can see the space right here shown. And you can actually see how much space I'm using. So now with the availability of write cache, though, you can see I'm getting a very heavy hit ratio of 99%. Because really, the only thing that's amiss are the simple reads that would go from the hard drives. They just hit one time, go into the cache, and from there, they're just fully acknowledged. So, so that's the reason that we can maximize this and why we give so much space for this. But anyways, you can change the SSD size right here. Just simply update it for the write cache. Or obviously, if you don't have any, you can just say 0 gigs and update. Within the storage pool, you can see our multiple tiers, how much space is kind of used, how much available space we have. We can see the arrays as well right here. And down at the bottom, there's a few nifty features for the tiering. So people say, can you adjust things? Can you change things? What about me? What's different about my environment, and what do I need to do? And so one thing, if you're doing a bunch of copying, if you know there's some back-end reporting that's going to happen for the month end, you can just simply stop the data movement if you want to. One of our competitors, they only do tiering during the evening. We have a workflow management algorithm that reduces the tiering automatically throughout the day and increases at night. But say you just don't want anything to happen during the day, you can just simply set this periodicity. And so what will happen is it'll only do data movement at these times. So you kind of have the versatility there. And then also the policy of what are we putting into the SSDs? So we have a demotion policy. So now if a block's on tier 1, so any part of a volume's on tier 1, and if it hasn't been accessed in a week or more, that's going to be up for demotion. So we're going to get that out of the SSD space. In this case, I have an SSD tier as well. So now if it hasn't been accessed in 3 or more weeks, that's going to be up for demotion, and that's going to go down to the nearline SAS drive. So we have this kind of waterfall demotion policy here, and you can adjust these settings. So you can say, you know what, I'll do 6 months here. I'll do 3 months here. And then also what you promote up there is actually another configurable setting. So we don't want just anything in the SSD space. By default, we do 64 and 32 just to kind of make sure that you get something up there. But you can kind of adjust all these policies. So you can say, you know what, unless something's hit 1,000, 500, 600 times, I don't even want it touched in the SSDs. So you can kind of adjust all these things. Just simply hit apply, and it's updated. It's good to go. And I'll just go ahead and do that just so nobody questions, oh, you didn't click apply because it doesn't work or something. No, it'll perfectly do that just fine. So you can kind of see those factors there. And so then within a volume, you have other versatility things. So here's just the generic space and provisioning. We support exact provisioning. You can see the target information right here, what IP to log into. And then here, actually, the snapshot schedules. Once an hour for just keep 5 of them. once a day, keep 5 of them. You know, once a week, just keep it for the month, whatever. You can change these settings. Say I want to keep 7 days worth now. Just simply update the schedule. And so now it'll start taking that automatic schedule as we go. Down here at the bottom, you can actually see the profile information. So this is the performance piece of each individual volume. This is my hello volume. I do have I/O just always kind of running to it. You can see right here it's getting about 20,000 IOPS, but it's got one heck of a load. It's got 8K mixed random workload here, and then it also has this other workload, 4K, 67%, 33% random reads and writes. So it's getting hit pretty hard. It's a lot of writes and all that stuff too. But you can see here we can change the cache profile on the fly. You know what? I don't want to waste any more acceleration on this. You can just simply update profile. You know what? I don't want this on a 15K SAS drive. I want this on my SSDs. So fine, we'll update the profile. So you can kind of adjust all these settings as you go. And so I'll just kind of change that back because I don't want that to not be accelerated with the SSDs that I'm showing here in the demo. We have SRM reporting, basic space utilization, so you can kind of see, we call it a container internally, so this is our storage pool space. You can see how much is used up for snapshots, how much is used for volume, so where are you at, where's your growth taking you, how long will you last, basically. And you can do that on the full-on view or on particular volumes. Volume performance, so we can see the read and write throughput of individual volumes. And so like I said before, we're doing 67% reads, 33% writes. That's exactly what we see here. You can scroll in, you can zoom into specific points, all that kind of stuff. And you can see here, this is kind of doing just 12-hour tests, and I just keep it on a loop, basically, just for demos and stuff like that. Which is a side note, if you ever want to talk to us, have a demo for somebody that missed this, whatnot, they're fully available for you guys to do. Like I said before, the workflow management policy. So here I'm doing a lot of migration. I actually just migrated my demo stuff to this unit because I wanted to upgrade another unit. So with that, it's doing a lot of background activity right now. But you can see here what we're doing is we're watching the predicted and actual foreground. So this is the actual I/O that's going to the unit. And so you can see when it's high, when it's low, and as it kind of goes through here. Now what we're doing is we'll reduce the amount of data that we have background-wise to make sure we're maximizing that space as we go. Information lifecycle management. So this is the tiering piece of this. So like you saw before, I had this volume set to medium. I just set it up to high. So now what will happen is all these blocks that are in the medium zone, so you can see that right here, these are just the new blocks on the tier 2, are basically going to promote back up to the tier 1. And you saw that performance. That performance was because of the SSD cache, not because of the SSD tier, obviously, because now it's demoted down. So you can kind of see how this kind of works out. And then what will happen is I just migrated this unit so we don't have class 2, class 1 data. But once we get this data, once it becomes a month older, so it'll start migrating over, it's going to start migrating down to this tier 3 right here. So these are the spinning hard drives. So you'll kind of see how that works out. Storage pool space, you know, I/O performance, you can kind of see IOPS, throughput, block sizes, the percentages, so you can really see underlying, what is this application doing to my volume? What's happening, you know, underneath? So we get a good view of what's actually going on performance-wise. And of course, we show disk latency, we show the array latency as well, all those kinds of factors as well. So pretty much sums it up, you know, generically. I guess one thing I normally show is the hardware health screen. And it just gives, and this is not for just the 3500i, this is for all of our units. We actually give a report, a full view of the unit. And you can kind of see different check mark items. You can see the network utilization right here, the percentage. These are 10G NICs, so 5% is 50 megabytes a second, and you can see 8% right here. So it's more substantial than it looks right here, I/O-wise. But we also show the performance on the disks. You can see the stars right here, so these are the SSDs. You can see the pink tags, all that stuff. So yeah, so that's pretty much everything. If there's anything you want to dig into, though, reach out, let us know. We can do a DR pair for you. We can log into a specific snapshot, show you a recovery type situation, whatever you would, you know, may want to see or do or whatnot. So I'll pass it back over to Tiger.
Very cool. Thanks so much, James. Yeah, we are just going to go ahead and start wrapping it up here. We only had a couple of time for like one more question or so. So the last question we'll have for the day, and again, like I said before, anybody who wants to still submit questions, you're more than welcome to still submit them to the email, and we'll just email you back a response later this afternoon. But the last question is fairly simple, straightforward, we'll get to is how long does a store trends array take to set up and configure?
Okay, so for installations, I'll factor 4 hours just to really get it, usually there's a huge consideration of, oh, we need to find network cables or we need to set up the VLAN on this switch or something. But quite honestly, once we ship it out, actually we ship it out with the arrays. We go ahead and configure them, initialize them, so when you do get them, they're actually ready to go. So it takes about an hour total, and that starts the training and the actual just getting going through the UI and exactly what kind of volumes you need to set up and all that kind of stuff. So in general, 2 hours, and you're completely trained. You know exactly how to do everything, and that includes going forward with later on things of adding volumes, changing space, expanding volumes, and all that kind of stuff.
Very cool, very cool. Well, we will just go ahead and take this opportunity to thank everyone out there for attending. We certainly appreciated getting to present to you today and hope that everyone enjoyed their pizzas and for this virtual lunch and learn. Just want to direct you guys to a couple of other questions that we had. Several questions came in regarding pricing information and all that good stuff. If you would just like some sort of no obligation, just list pricing, just to sort of get a general idea what a different configuration would go for, you could go on to www.storetrends.com as seen on the questions and answers slide a little bit earlier. And like I said, www.storetrends.com. There's a price quote configurator on there. Put in the information that you like, and then we'll send you over a list price. Again, no obligation or anything like that, just to have you get a ballpark of what you're looking for. And again, like James mentioned before, Store Trends iData. If you want to get a better view of your environment, that's available on the website as well, totally free, and can certainly provide good information for your environment. So with that, I'd like to thank again James Dyckowski for sitting in on this with us and giving the presentation. Thank you, James. And looks like we're just about 2 minutes ahead of schedule here. So thanks, everybody. If you have any questions, again, feel free to email tylerin@ami.com. Other than that, we'll see you next time. Bye-bye, everybody. Thank you.